Namaste and welcome back. I am Dr. Naresh Bana, and today we are going to discuss offshore wind farms. Yes, the wind power projects located offshore in the sea.
This is a vessel used for carriage and erection of the towers on the foundations, and thereafter hoisting the turbine on top of the towers. The entire process was so designed and executed that 100 turbines were installed in 100 days. A remarkable feat indeed.
Let's talk about how and when the wind farms first originated. It is reported that 3000 before Christ, Persia had wind farms for irrigation and grain milling. Then thereafter, UK and Europe have been recording it as source of power. But first commercial wind farm was set up by Denmark in 1957, and the oil embargo of 1970s and 80s further fueled the requirement, and countries started setting up wind farms after wind farms. The last decade of 20th century saw large-scale expansion led by Denmark and UK. But maximum development happened in 2010s when 100 gigawatt, yes, 100 gigawatt of wind power added globally. By 2020s, wind power surpassed 700 gigawatt globally, and the growth in Asia was led by the China, and overall wind power became more than 7% of the total power production in the world. The offshore turbines of 1990s in Denmark were primarily 5 megawatt rating, and 11 were set up first. Then in 2010s, UK's Thanet wind farm had 100 turbines of 3 megawatt each, followed by Germany Alpha Ventures 12 uh, towers of 5 megawatt each, and China on Dongai Bridge had set up 34 turbines of 3 megawatt each.
This was China's first offshore wind farm, with overall capacity of 204 megawatts.
In 2020s, global capacity expansion surpassed 50 megawatt, and the largest wind farm was set up off the Yorkshire coast in UK, where 174 turbines of each having 7 megawatt were set up. It became operational in 2019. Asia remains led by China. You may be surprised as to why offshore wind farms are being talked about when it appears that they would be more costlier and more difficult to maintain. Let me give you some advantages of offshore wind farms. First and foremost, the turbines function more efficiently in offshore, and the capacity utilization factor could be as high as 50% in comparison to 35 or 25% when they are set up onshore. The visual impact, which is one of the major drawbacks of wind farms when set up onshore, is reduced when the same are set up beyond sight in the sea. The noise pollution is also taken care when the wind turbines are set up offshore, and since there is vast surface available, large scale deployment can take place and the economies of scale can be achieved. The grid stability is also reported better by the power generated from the offshore farms. Today, the technology permits that we can have larger and more efficient turbines for offshore farms. Even the foundations of such towers could be floating, and use of advanced materials really makes them versatile when deployed offshore. The costs which are higher are taken care or compensated by economy of scale, supply chain optimization, and the continuous R&D, government subsidies, tax credits, and renewable portfolio standards. Let me talk about the case of 174 turbines off the coast of Yorkshire in UK with the project which is called Hornsea 1. Its total capacity is 1.2 gigawatt, that is 1200 megawatts, and it is located 120 kilometers from the coastline of Yorkshire. It is developed by Ørsted, formerly Dong Energy, and there are total 174 towers. The total investment in this project, which became operational in 2019, is US dollars 3.4 billion with a 50% equity and 50% debt, and debt tenure is 15 years with 5 years grace period. The environment risk is with elaborate EIA and regular monitoring. The financing has a lot of innovations, and one of them is contract for difference with the government of UK, wherein due to the uncertainties of such large scale project, the differences which are envisaged at the time of construction or and what it appears finally at the time of commercial operations will be taken care with discussion with government of UK. The strike price has been fixed as 18 cents per kilowatt hour, and expected annual revenue is $300 million from the project. The risk mitigation is quite elaborate, wherein the construction risk is taken care by keeping a fixed rate contract with Siemens, and technology failure risk is mitigated by having turbine warranties and maintenance agreements. Weather damage is taken care by insurance and design efficiencies. Transmission risks are taken care by offshore transmission owners agreement, and as I mentioned, the financing is with diversified lenders. The lessons which emerge from this project is that economies of scale are useful, beneficial, profitable in such large deployment of turbines, and due to technology advancements, the offshore is becoming more and more profitable. The financing innovations using hybrid structure of equity and debt and a comprehensive risk management always has its own dividends. The government support is essential, and it always proves to be beneficial if you have efficient supply chain management and environmental concerns are to be taken care regularly, and it should be an ongoing process. With all this elaborate orchestration of resources and deft execution, the Hornsey 1 started production in 2019 and it's powering 1 million homes. The Ørsted's model of financing and execution has been replicated by many promoters worldwide thereafter. In India also, we are having the tenders now for offshore 500 megawatt off the coast of Gujarat and for 4 gigawatt off the coast of Tamil Nadu, which will be finalized in next few months, and Indian offshore wind power journey, which has already begun, will start showing some tangible results. Thank you very much for being with me, and we will be back with more on offshore and many other PPP issues. Till then, keep watching. Namaste and have a nice day.